Hello everyone, this is Vamsi Kumar. In today's session, we are going to discuss about a WER data model. So WER data model is an extension to the ER data model. So we already discussed what is meant by ER data model. In that ER data model, they are adding some additional functionalities or features. So that is called as a WR data model. So if you observe the definition of WR data model, WR is a high level data model that incorporates the extension to the original ER data model. So what is the full form of the word WR data model? WR stands for Enhanced Entity Relationship Data Model or Extended Entity Relationship Data Model. In this WR data model, we have four different concepts are there. Based on those four concepts, it is possible to implement the WR data model. What are those four concepts means? Subclass and superclass, specialization and generalization, union or category, aggregation. So now we are going to discuss about those four concepts in detail. So what out of those four, what's the first one? Subclass and superclass. So subclass and superclass relationship leads to the concept of inheritance. I think all of you know about the purpose of an inheritance. What is meant by an inheritance? Inheritance is nothing but it is a mechanism of deriving a new class from an existing class. Okay, a new class inherits the properties or features of another class is nothing but an inheritance. So here there is a small difference between the subclass and superclass. Whenever we are representing the relationship between superclass and subclass, we are representing it with and one symbol. What is that symbol? Means a D within the circle. This is the symbolic diagrammatic representation in between subclass and superclass. And next, what is meant by superclass? So a superclass is an entity type that has a relationship with one or more subtypes. Every superclass has a set of subclass entities. Okay, a superclass entity has set of some attributes. By using those attributes, new subclasses will be formed. For example, I'm considering a shape superclass. So every entity has a set of attributes. So shape class also has a set of attributes. What are those means? Every shape has a name. Every shape has a certain number of vertices. So based on those attributes, new subclasses will be formed. What are those new subclasses means? Square, circle, triangle. Okay, so this is the purpose of superclass. Now coming to second one, subclass. So what is mean by subclass? Subclasses are the group of entities having unique attributes. Okay, we have multiple subclasses, but all those subclasses must and should have unique set of attributes. Subclass inherits the properties and attributes from its superclass. A subclass derives the properties or attributes of superclasses. Okay, so whatever the example we considered in previous, the same example, shape is the superclass name, and the subclasses are circle, square, triangle. All those are having a unique attributes. So what are those unique attributes? Means circle entity has a name called circle, and the second entity square that has a name square. How many vertices? Means four vertices. Triangle, it has a three vertices, and it's and the shape name is triangle. So based on those unique attributes, the new subclasses will be formed. So if you observe this diagrammatic representation, shape is the superclass name. Based on the shape superclass attributes, the new subclasses are formed. What are those means? Square, circle, triangle. In between the superclass entity shape and the subclass entity types, we are representing one symbol. That symbol is called as a D within the circle. It means the it means it is an implementation of the inheritance concept. Okay, and next one, generalization. So what is mean by generalization? Generalization is nothing but whatever the entities, lower level entities we considered, all those entities are combined to form a new entity, that is called as generalization. Whatever the similar entities we considered, though after combining those similar entities, a new entity will be formed. In generalization, we are following one approach. That approach is known as a bottom-up approach. Okay, so if you observe the definition of generalization, it is the process of generalizing the entities which contains the properties of all the generalized entities. Here we are generalizing all the entities. It means combining all the entities. Whenever we are combining, a new level entity will be formed. See the example. So we already discussed it is a bottom-up approach. In this approach, whatever the lower level entities we considered, after combining all those lower level entities, a new entity will be formed. Okay, and also it is a reverse process of specialization. See the example of generalization. I'm considering some lower level entities like lion, tiger, elephant. All those are lower level entities. All those have similar properties. Those all are animals. So after combining all those lower level entities, a new entity is formed. That new entity name is animal. Okay. So this tiger entity is an animal. Lion is also an animal. Elephant is also an animal. So in between the superclass entity animal and subclass entity names, we are representing the relationship name is easier relationship. In specialization and generalization, whatever the relationship we are trying to map in between entities, we need to use the relationship that is easier relationship. And now coming to second one, specialization. It is the reverse process of generalization. So once see the definition of specialization, it is a process that defines a group of entities which is divided into sub-entities. It means whatever the entity we considered, that entity is divided into number of sub-entities. How it is possible to divide means based on their entity characteristics. Okay, it is a top-down approach. One entity is divided into number of sub-entities. See the example of specialization. I'm considering the employee entity. For suppose, if you consider an organization, number of, if you consider a software company, number of employees existing in that company, but all those employees are not, their work is not similar. Based on their role, the employees' work is different. For suppose, some employees belongs to developers and some other are testers. So based on their employee role, uh, there are different types of employees works in an organization. Here employee entity is divided into number of sub entities called as developers and testers. Okay, so this type of approach is called as a top down approach. We are dividing a higher level entity into number of sub level entities, sub entities. Okay, so that is the difference between the specialization and generalization. If you observe this diagrammatic representation, both the specialization and generalization are implemented in a single diagram. Once all of you see this, once if you observe this diagram, total three entities are there. First one is student, that is the superclass entity, student, and second one undergraduate, and third one graduate. For suppose uh, a student entity, a student higher level entity is I'm trying to divide it into number of sub entities. How it is possible? Based on their student levels wise, I'm dividing. Okay, some are undergraduate students, some other are postgraduate students. This type of division, this type of categorization is nothing but specialization. And see, coming to generalization, uh, all the undergraduate and postgraduate, all those are belongs to students. We are combining the undergraduate students and graduate students and those are belongs to a student. Here we are following the bottom up approach. So that is the difference. In generalization we are following bottom up, in specialization we are following top down. Okay, so that is the difference between the specialization and the generalization. Now coming to third one, category or union. So what is the purpose of this concept means it is nothing but a multiple inheritance. I think all of you know about the purpose of multiple inheritance. What it means, in multiple inheritance we have multiple base classes but only one derived class. That derived class having the features of one or more base classes. So category represents a single superclass or subclass relationship with more than one superclass. I'm considering one example to implement the category concept. What is that one means? A car booking or a car owner can be a person, a bank, and a company. So I'm trying to implement this example in EER data model. See once all of you. If you observe this diagrammatic representation, the total three superclass entities are there: person, bank, company. What is here out of those three superclass entities? What's the first one? Person. A car owner may be a person, or a car booking person may car booking person, and the second one is bank, and third one is company. Uh, Based on those superclasses, a new subclass will be formed. That subclass name is owner. So what is the main theme of this example means, I am trying to buy a car on a loan. For suppose I am trying to buy a car from a person uh, with some loan in a bank. So I'm a owner, but I am buying a car based on the person superclass and the bank superclass. Okay. In the similar way, I'm trying to buy a car in a particular company like a Hyundai or Maruti on a loan in a bank. So those two are the superclasses. By using those two superclasses, a new subclass will be formed that is called as owner. Without those two superclasses, the owner subclass will not be formed. Okay, now. So what is the purpose of category concept means, based on the superclass entities, a combination of one or more superclass entities, then only a new subclass will be formed. Okay, so that's the purpose. A category member must and should exist one or more superclasses. And the last concept, that is aggregation. So aggregation is a process. It represents the relationship between a whole object and its component parts. So what is the purpose of this definition means, whenever we are representing a relationship between entities, there may be a chance of sometimes there may be a chance of getting a relationship in a proper manner. So by using the concept of aggregation, it is possible to implement that relationship concept in a proper manner. So how it is possible? In this aggregation process, we are treating two entities as a single entity. So see the example, a student attends a course. So in this example, how many entities are there? Two entities are there. What are those? One is the student and another one is course. A student trying to attend a course. A student is trying to attend a course. So whenever that student is attending the course, attends the course, what it will happen? He will gain some knowledge on that particular subject. Okay. In the similar way, whenever a student attends a course, then only the student will gain a knowledge on that subject. Otherwise, he can't get a knowledge on that particular subject. Okay. So here there is a one more relationship, that is a has relationship. This relationship is formed based on the attends relationship. Okay. Whenever there is no attends student and not attends to a course, then the student will not gain any knowledge on that subject. So that's why here the has relationship is applied on attends relationship. So in this process we are applying the aggregation process. How to apply the aggregation process means, if you observe this diagrammatic representation, student attends a course, those two entities are those two entities relationship will be treated as an entity. So that's why that entire relationship is represented in a rectangle. So all that entire relationship will be treated as a single entity. That entity name is student course. That is the one entity. And another entity is subject. So whenever the student attends the course, then only the student will gains the subject, will gains the knowledge on that subject. Okay, so this is called as an aggregation. In previous we already discussed what is meant by aggregation. Means aggregation is a process which combines two entities as a single entity. Okay, so here the student and the course entities will be treated as a single entity. That entity name is a student course. In that student course entity is related with the subjects entity, with the relationship has relationship. Okay, so this is about the aggregation concept. So these are the four different concepts of WER data model. So by using these four concepts, we are representing the WER data model in a proper manner. Okay, so this is about a WER data model. Thank you all. Thank you.